Welcome and thank you for standing by. All participants will be in a listen-only mode until the question and answer session. During that time, if you'd like to ask a question, please press star one. I'd like to inform all parties that today's call will be recorded. If you have any objections, you may disconnect at this time. I'd now like to turn the call over to your host, Ms. Tiffany Fairley. You may begin whenever you're ready.
Thank you. Good afternoon. I'm Tiffany Fairley with NASA's Office of Communications. Following the previous wet dress rehearsal runs, engineers identified an issue with the helium check valve that was not functioning as expected, requiring changes to the test to ensure safety of the flight hardware. NASA is planning to proceed with a modified wet dress rehearsal test focused on using the ground systems at the agency's Kennedy Space Center in Florida to load propellant into the Space Launch System rocket's core stage tanks with minimal propellant operations on the upper stage. The team achieved many of the wet dress rehearsal objectives during the two prior tests, and the modified test will enable engineers to achieve the remaining test objectives critical to launch success. Due to the time needed to adjust loading procedures, testing is scheduled to resume with call to stations at 5 p.m. Eastern Time, Tuesday, April 12th, and starting Thursday, April 14th. The T0 will remain at 2:40 p.m. Eastern on the 14th. Here to provide us with an update are Tom Whitmire, Deputy Associate Administrator for Common Exploration Systems Development, NASA Headquarters, Charlie Blackwell-Thompson, Artemis Launch Director, Exploration Ground Systems Program, Kennedy Space Center, John Blevins, SLS Chief Engineer, NASA's Marshall Space Flight Center, and Mike Serafin, Artemis 1 Mission Manager, NASA Headquarters. After brief opening comments, our speakers will take your questions. We'll begin with remarks from Tom. Tom?
Thank you, Tiffany. Before I turn it over to our launch director, Charlie, and the chief engineer, Dr. Blevins, let me just say a couple things real quick. We've got a great team that have looked at the experiences that we had. I think Charlie did a great job talking about what we learned from the last test activity. Our team has sat down. We've gone through all that data. We have what we think is a very good path moving forward. It's kind of a step-by-step approach. We have completed a lot of the test requirements that we needed to get out of this wet dress activity. We have a few more that we're going to get to on Thursday. The Mega Moon rocket's in great shape. We're treating it very carefully, and therefore we're going to limit a few of the objectives that were coming up on Thursday. But for the most part, we're going to get a lot more data coming out Thursday. I'm very excited about that. Charlie will talk about the test and what we're going to be doing on Thursday. John's going to talk a little bit about what we learned with the helium purge system, and so you'll be able to ask him questions. And then Mike's going to finish it up with some more details about getting ready for the mission. So all in all, we're very comfortable with the path forward. We think it's a great path forward. We're learning a lot about this rocket. And any new rocket that comes forward in a new program like this kind of goes through these updates and understanding how the rocket is performs, and that's the type of thing that we're going through right now. But we have a great team. They're really confident about what they're doing, and we're going to move forward, and we're going to do a test on Thursday. And with that, I'm going to let Charlie talk a little bit about that test.
All right. Thank you, Tom, and hello, everyone. Our teams have been doing an excellent job since we last spoke to come up with the best plan to move forward for our next wet dress rehearsal attempt. As was mentioned in the latest blog post, we are looking at doing a modified wet dress rehearsal, which involves loading and draining propellant on the core stage, getting into our terminal count operations, and then doing some chill down operations on the upper stage. So we will be in a modified test configuration for wet dress. Our timelines for the test, though, remain the same because we want to validate our timelines and our ConOps, and so we didn't actually go in and take out any significant time out of the test itself. We believe that this is the best option moving forward. We'll talk a little bit about what got us here in just a few minutes, but we believe that we'll be able to meet the majority of our test objectives and provide us with a really good set of data prior to rollback. And so just to reemphasize some of the objectives that we have. We do demonstrate the cryogenic loading and drain operations on the core stage. That is one of our primary objectives, and we will do that on Thursday. We do intend to recycle back to T-minus 10 minutes and go through terminal count a second time. The piece of that we will be missing will be the upper stage portion of that. We also have already completed and activated our Launch Complex 39 and the KSC Launch Control Center in our launch countdown configuration, which is another one of our primary objectives, where we also demonstrate our ability to communicate with the design centers, the Eastern Range, and our flight control team. We have essentially completed that objective. We will, of course, get the terminal count part of that on Thursday. We also have a number of secondary objectives. As I mentioned, we've already demonstrated our successful launch control interfaces. That objective is behind us, and we will be collecting data on the Orion SLS and mobile launcher configuration in our cryogenic environment. So we'll be doing that on Thursday. So there's a number of our objectives that we will continue to, the ones that are partially complete, we'll get some additional data on them, and as I said before, many of our objectives have already been completed. A little bit about this particular issue. I'll describe it, and then I know John Blevins will provide some additional information on the issue that kind of got us to this configuration that we're in. So during our post-ops from wet dress run number 2, we did have some helium leakage was identified from a helium supply inlet fitting down in the mobile launcher base. And this was essentially, it provides, this control regulator provides helium control pressure to a reg that ultimately provides helium to the upper stage COPVs. And the team went in to do some troubleshooting on that. As part of that work, they ended up replacing the leaking component, and during that time, the COPV, they reduced the COPV pressure as part of that troubleshooting. When they had that part repaired and they brought pressure back up, they failed to see the expected pressure on the onboard, the COPVs or the helium bottles on board the upper stage. The team did troubleshoot that, and on Friday they were able to determine that it looked like the issue was on the flight side of the interface, and that's when the team began to look at the test configuration, and we began to make some modifications to the planning for the test on Thursday. And I'll talk a little bit, I'm sure in the questions, about what that test configuration looks like, but for now I'll hand it over to John and let him talk about the issue with the check valve.
Hey, thanks, Charlie. First of all, let me just say that the vehicle is really in great condition. It's doing what we ask it to do, except for this one exception for this check valve. And so, just to emphasize, we had a pretty good test the other day, and I'm really pleased with seeing how the vehicle is responding. And I do also want to point out that I think these modified procedures and this modified WDR that we're about to do, the one Charlie just explained, really will cover a majority of the things that I've been interested in, the vehicle's interested in. We're going to do that core stage tanking. That's the huge new piece of hardware and the largest cryogenic tanks. It's going to check out a lot of software switching, even our APUs on the boosters. So there's a lot of objectives I don't think people see. It's much more than a tanking test. And as Charlie mentioned, there will be some work on the ICPS and the chill down. And that stage is a reliable stage. It's got some heritage history, and I think that information we're going to get will provide a lot of detail to lead us toward the next phase. But when we did that ICPS checking, ICPS testing, as Charlie mentioned, after that ground system component was changed out, which really wasn't in the line per se. It was a dome load regulator, so it's outside of the normal line of the helium. But we needed to lower that helium. When we went back in, we did detect an inoperative check valve, and the way we did that is it just wasn't getting the right pressure drop, and then we did a reverse flow check. If you know what a check valve is a one-way valve. So a reverse flow check should just mean everything stops, and it didn't stop. And so we knew that check valve was not operating the correct way. Let me just mention and pause for a moment on check valves. We use the term valve a lot, and some of these valves that we use, like the pre-valves, for instance, on the core stage, we need a crane to hold them while we operate on them. This is a check valve. It's 1 1/8 inch in diameter. It connects to 2 1/2-inch lines. Nipple to nipple, it's 3 inches long. And so it's a very small part. You could put it in your pocket. It's also a very high reliability part. We use check valves in just about every aerospace or even non-aerospace application I can think of. We have them all over ground facilities and everything. And so it is somewhat of an unexpected outcome, an unexpected failure, but when you have a failure like this, you stop and you evaluate why it's doing that, and we'll be able to do that when we get to it. This check valve is in a place that doesn't have great access on the launch pad, but once we get back to the VAB, it's pretty easy to get to. It's just inside of an area we can put platforms, we can stand up. It's about chest high. It's mounted to a board. A lot of check valves are just suspended by lines, but this one's, because they don't weigh much, but this one is mounted to a structural board right inside the ICPS. And so easy to get to, easy to change out, and I really have hesitated from speculating about why it's not operating right, because in about a week and a half I'm going to know why it's not operating correctly. And so that's kind of the summary of the check valves. I do just want to point out a few other things, and really that we do monitor the vehicle all the time. And so this was pretty easy to find out when it occurred. While it's sitting out there on the pad, while it's been doing the PSET, the program-specific engineering testing, we've been monitoring pressures and temperatures as an EGS-SLS partnership. And so when we pressurized this system immediately after that component change, we knew that we had a little bit of issue. And so we set about to do a very thorough and detailed set of tests, and those tests clearly show that the check valve's not operating. And so, but I'm very confident that we're going to have a good test on Thursday with the modified procedures, and I think we'll learn a lot.
And finally, we'll have remarks from Mike.
Okay, good afternoon. I'll keep my comments brief, but I did want to provide a little bit of context for the wet dress rehearsal and put it in the broader context of the test flight program that we've got in place for Artemis. As you recall, Artemis 1 is an uncrewed test flight that is intended to set us up for a crewed lunar flyby on Artemis 2. So Artemis 1 is part of that test campaign, and it's part of a classic build-up approach. And as we learn things and experience issues, we account for them and adjust as necessary. And this is one example of that. The team has worked through a number of challenges thus far, as we've discussed in the past 2 weeks, as well as prior to that, and has handled each and every one of them with grace while under pressure. The team right now is focused on taking the necessary time to get this upcoming test right, and we thank each and every one of you for your patience as we work through these challenges. I can say that these will probably not be the last challenges we'll encounter, but I'm confident that we have the right team in place, and the ability to rally around those problems and overcome them is something that we take pride in, and we absolutely have the right people in place to do. So that's my comments. I'll turn it back to you, Tiffany.
Thank you so much, Mike. We'll now begin the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. You can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue. Shortly after we conclude, you can listen to a replay of this teleconference online. We'll begin with Bill Harwood from CBS News.
Yeah, hey guys, it's Bill Harwood, CBS. I just want a little clarification of what the big picture objective of the test was. I think a lot of us were under the impression you really did need to fuel up the whole thing. And John, I realize you're testing lots of stuff besides just tanking, but our impression was that you were going to gas it up and take it down to terminal count. How is it okay to not test the second stage in that same way? In other words, I realize that the ICPS has flight heritage from Delta IV Heavy, but what gives you confidence that once you get back out the pad on launch day that everything's going to work the way you want it to? Thanks.
Well, let's see, Bill, I'll give you a perspective on this particular question. So the wet dress rehearsal was about a number of different things. It certainly was about loading cryogenics in the core stage. It was about loading cryogenics in the upper stage. It was about testing out the Launch Control Center, all of the GSE, our sister control centers located at Johnson and at Marshall, and making sure that we are all able to operate along the timelines and in a day of launch environment. And so given that we have this particular challenge in front of us, what the team has done is looked at what of those objectives can we go and accomplish without loading the upper stage. So we want to get as much data as we can while we're at the pad. Once we get this data, the data will lead us and tell us what we need to do next.
Yeah, Bill, I have to agree. This is Tom. I have to agree with Charlie. We went through something similar at Green Run where we had a lot of test data. We went through some tanking activity, and we made a decision to go into a hot fire opportunity if we were successful in completing the final tanking. I don't know where we'll end up on this one. We really need to get to the test on Thursday to see what we find out from the testing. We also need to get the vehicle back in the VAB to see what we see with the helium purge system. But if you go through, and Charlie's mentioned, there's a lot of the objectives that we had established before we started this process that are either accomplished at this point or will be accomplished as we go through the test. I don't think we're ready to really state one way or the other what we think the next step's going to look like. I think we really do need to do the test Thursday. We will introduce cryogenics up to the area, but not into the tank. We'll look at the performance of the vehicle. We'll look at the performance of our ML system and our LCC, and we will go through a terminal count sequence and get a lot of things accomplished. And then I think what we'll do is that we'll take that data, take the valve that John talked about being small enough to put in your pocket and take a look at that, make sure we understand what's going on with the valve. And then I think that's the right time to kind of think through what our next steps look like. But right now, I don't think we're ready to do that. I think we need to go through the test on Thursday. And I know, John, do you have any additional thoughts on that? Or?
Tom, I think you've got it right. We're going to do a lot of testing, and the data is going to lead us, as Charlie said. We're going to do some things up there on the ICPS that are unique to this ground system. And that data will be invaluable in making the next decision.
Thank you. Next, we have Irene Klotz, Aviation Week.
Thanks. Dr. Blevins, could you go through the structure of what this system looks like from the mobile launcher up to the ICPS and where the COPV bottles that can't be pressurized are located and how many there are and how many are then affected by this check valve problem? Thanks.
Yeah, and let me make one correction. We may have misspoke or misled you guys. There is pressure in the COPVs. We can pressurize the COPVs. We have a faulty device in the system, and that's caused us to use caution because the whole point of wet dress is to decrease risk. And at the point where you start adding risk to the hardware is when you stop adding functions to WDR and you might take them away. So we do have pressure in the COPVs. In fact, that pressure in the COPVs is providing purge gases to the RL10 engine in the ICPS at this very moment. So we probably misled you that the check valve is not failed closed. The check valve will not stop reverse flow. And so we have decided to quit adding additional pressure, if you will. We're adding a consistent flow rate through that check valve to maintain COPV pressure sufficient enough to purge our engines and do other functions. And so just as a point of clarity there. Let me explain the system, though, since that's the question. We've got a helium ground system. In fact, it's got redundant legs to make sure we get up there, and it's controlled all the way from the bottom of the mobile launcher, goes up to the level right where the ICPS is. I think this may be level 260. It's a pretty high level in the vehicle. And up there we have a hand regulator panel that we also have. That goes to a flex hose that goes to a QD, quick disconnect valve. We've got one of those on the ground side. We got one of those on the rocket side. And then the rocket side itself is simple. It's got the QD that connects to that ground side. Then it's got the check valves. Then it has the bottles. Now, when it leaves those bottles, it goes to various functions. And every one of those functions has filters. They go through regulators in order to supply helium gases to different operations. It can be valve operations on the vehicle. It can be when we evacuate the oxygen tank on a wet dress rehearsal, we'd be using helium, and it's that increased demand is why we're not adding that particular propellant in this test to any substantial amount. And then it also goes, as I already mentioned, continuously in our current state to the RL10s to keep them dried out as a purge. And so I think that hopefully that described it well enough to you. It's really not a complex system. It's really a pretty simple system.
Thanks. And how many bottles are there?
Oh my, I think there's 6. How many? 8.
The 8
8.
bottles.
8, thank you, yeah.
Thank you.
Thank you. Next, we'll have Eric Berger with Ars Technica.
Hi, thanks very much for doing this. A couple of questions kind of about the sort of the timing here. First of all, we haven't talked a whole lot about the secondary payloads, but I think they were installed last July. And I'm just wondering how they're doing, the batteries on those holding up, that kind of thing. And then second of all, could this valve problem be delayed? I know you say you don't want to talk about sort of causes or anything like that, but the ICPS has been there for about 4 years, and so I'm wondering if you start to worry about these kinds of shelf life concerns with this vehicle. Thank you.
Yeah, Mike, I think you could probably answer the CubeSat one, and I can answer the vehicle life.
Yeah, Eric, on the CubeSats, the secondary payloads, we are doing fine on those. Prior to rolling out of the VAB, we did a top off of the battery state of charge, so that was in the February time frame, and we keep track of the battery state of charge based on the battery characteristics and predicts, and we've got ample margin here. But if we needed to, we could top off the battery state of charge again once we get back in the VAB. Tom, I'll let you handle the other question.
Yeah, and Eric, it's a good question on the limited life. We're tracking all that, as I'm sure you're aware, both the vehicle and for Ryan and the rocket and other related systems. And right now we have plenty of margins. That's not really something that we're seeing as being a limiting factor, and certainly something that wouldn't change our thought processes at this point. We feel like we need to be more focused in on the plan. We've got, I think, well into the fall, and then we have options in the fall if we need to look at specific systems and extend the life. That's a standard practice that we've had to do before. It just means you have to sharpen your pencil and look at the actual environment that the hardware is seeing and kind of do some more math. So I think we're okay. We really don't see that as the limiting factor at this point. Certainly the fact that what we're seeing, for example, with the check valve is really the first thing we've seen on the vehicle during this flow that's really kind of a flight side item, and everything else has just been, valve in the wrong place and things of that nature. So I think we're still feeling very confident about this path forward. But Dr. Blevins, I don't know if you have any additional thoughts. Obviously he's the chief engineer for SLS, so you can just add anything I'm missing at that point.
I don't think shelf life on this component should be a factor whatsoever. Tom, you covered it very well. There's a lot of components that we track. We track all of them with the shelf life. There are DSSs, the Delta second stage, which this is a derivative of, that have been on the waiting list longer than this one has to fly after manufacture. So I don't think that's an issue either for almost any of the components, but certainly for a check valve. They're usually 20, 30-year type products. They're not usually life limited in this way.
Thank you. Next, we'll have Jeff Faust with Space News.
And specifically, what test objectives will you not achieve with this modified flow for the wet dress rehearsal? And what fraction of the overall test objectives is that? And do you have alternative means of collecting the data you would need to meet those test objectives outside of the wet dress rehearsal itself? Thanks.
Yeah, I want Charlie. I'll actually add something when Charlie's done. I'll talk about that. We've given this a lot of thought. But Charlie, go ahead. And I think she talked about it to start with, but we're actually getting a lot of test objectives done and a lot of the critical timing sequencing ones that we really do worry about in terms of vehicle commands. But I'll let Charlie go through that again.
Yeah, I think Tom covered it. Maybe just to give a little bit more. We do get the critical timing, we get the control center checkout, we get a lot of the GSE checkout. The piece that we don't get is that very specific to the upper stage piece. And so we will be missing those loading operations for the upper stage itself. But in terms of critical events, when we did sit down and, as we were looking at this modified plan, we sat down on Friday afternoon as a team and we looked through what are the critical events from like T-10, because you could we looked at what makes sense, what tests make sense to go do while we're at the pad, and we certainly believe that there is great benefit in getting the core stage loaded all the way to replenish, and buying down, that risk associated with the stage. And then we went and looked at, okay, what about getting into terminal count, and what are those functions that we get in terminal count? And when you go look at the very specifics of that, and it depends on how you count some of these, but just a rough order of magnitude, if you look at your WDR, your critical events, from T minus 10 down to the just inside of 10 seconds, there's about 25, I would say, critical events that we list as part of these test objectives for terminal count alone, not including the things that happen before you get to terminal count. 2 of those are very specific to ICPS, so you're getting 23 of 25. And then when we went and looked at our GLS commanded events, those events that are, we got some of them in our countdown sequencing test but that's not in a cryogenic environment, but we got some of them there. But when we went and looked at them from T minus 10 down to just inside of 10 seconds, we have somewhere on the order of about 75 to 80 functions that we are commanding, and 3 out of those 75 to 80 are ICPS unique. So, there is a significant amount of testing and data and risk buy down that you get relative to core stage, that you get relative to the ground systems, that you get relative to the boosters. So.
Yeah, and I just like to add, when we get through the test, we really want to see how we do on Thursday. So we're not trying to, get ahead of that, and we want to get the vehicle back and we want to inspect it. Those are really important to us. Even the pumps that we use to pump the locks that's going to go into core stage are also used for the upper stage. So, to be honest with you, there's just we have demonstrated a significant amount of the activities, particularly the critical timing sequence and command control activities associated with the rocket that are really important to us. We'll take, we haven't done this yet, so we'll take a look at where we're at after we get done with this test and ask ourselves, what's the right next step. But I'll be honest with you, you're really getting down to a limited number of things, and there's a risk I don't say there's a risk, but there's a value to actually continuing to take a step-by-step approach. It's very similar to what we did at Green Run in terms of the logic path that we would go through at that point. And really for today, we want to talk about just getting ready for this test. After the test, we promise we'll come back and talk to you about here's what we got, and this is the competence that we built through this test, just like the competence we built in the earlier test, and then here's what we think is the right path forward. And we're just not ready for the right path forward part because we want to really get through this test and see what the vehicle talks to us about. But once again, outside of this check valve, it's about, and I think Dr. Blevins was very good at describing this about the size of your fist. That's really the only piece of flight hardware that we've had a problem with since we've been processing at the Cape. So we're really feeling comfortable with the rocket, and we will have really checked out most every command that Charlie would normally sequence through. A great majority of those will have been demonstrated as we get through this test profile. I think after all that, when we're done with Thursday and we learn more about the valve when we get it back to the VAB, we'll absolutely come back to you and share that with you and try to explain to you what we think is the right path. And right now, I don't think we're ready to do that. I think we want to see the test activity first.
Hey, Jeff, this is Mike Seraphin. I'll just add one point to emphasize what Tom just said, and that is, when we get to the end of this test program, and we're still working our way through it, we have the flight readiness review cycle and the flight readiness review process, and as part of that, you got to have flight rationale. So, regardless of whether we get everything we want in testing or we have a few unexpected results, or we are unable for one reason or another to test everything to the full extent that we'd like to, we still have to go through the flight readiness process and develop that flight rationale, and that process is in front of us. So that's probably the only thing I'd add.
Yeah, and the only thing is we have many systems in place to protect the vehicle throughout all these activities. So I just think we need to wait. But I think we'll be able to talk more about that when we get through Thursday. But we're really comfortable with our systems. We're comfortable with our safeguards. Up to now, they've done a fantastic job. We're just working through timing and sequencing, and actually we're getting good at it because I've sat through and listened to Charlie and his team do these operations, and one thing that's coming out of this is that they're getting a lot of experience working with the vehicle, and I think we're developing a lot of confidence in it. So.
Thank you. Next, we'll have David Curley with the Discovery Channel.
Thanks very much, everybody. John, I'm guessing that these valves are after the bottles, not before the bottles. And Tom, you said you've learned a lot about the vehicle. Is it a finicky vehicle? Is it a solid vehicle? What's your assessment?
Yeah, I'll let John talk about valves, and we can't get too specific about the design, so I don't know how best to answer. Don, I'll let you handle that one, and I'll talk about the vehicle.
Well, this one's an important one I think everybody would want to know. And the check valve is before the bottle. The point of the check valve actually is for when we depart on launch that we don't leak any. In fact, we have double sealing. The QD itself seals the quick disconnect and the check valve, and it prevents the bottles from being evacuated during ascent, and that's why we have that double redundancy. So it's between the bottles and the outside skin, if you will, the QD of the check valve, and it's really kind of a tight, pretty quick area. I mean, it's just QD, check valve, bottles, and lines in between. That's it. So simple setup.
Yeah, we're feeling pretty good about John and I both have a lot of experience with the hardware that is on the vehicle. A lot of this hardware was derived from the shuttle program in terms of its design. It's been modernized. It's performing very well, actually. Literally, this check valve, of all the valves and all the electronics and all the other hardware on the vehicle, it's the first thing that's really been on the flight side that we've seen since we've been processing at the Cape. We've had a little things. A lightning strike, obviously, is something you don't predict for. It was a very unusual thing to have happen right before wet dress. We had a fan go down. That's a ground system fan. There's a valve that wasn't in the right position. I mean, these are not anything to do with the vehicle. And they're the type of things you kind of get through as you go through a first-time activity. But in terms of the Mega Moon rocket, it's really doing very well. It's not finicky. It's a great rocket. One check valve is really the only experiences so far, and we're actually very happy we spotted it. The one thing about this business is you take this as a gift, that you've seen something, we want to learn more about it, see if there's something we need to understand here. As John said, it's not something we would have expected to see. And anytime you run into a situation like that in our business, you accept that as a gift, that was a great thing. This is why we test. That's the purpose of these test activities. All the monitoring we do, all these experts that we have, is to look for these type of situations, spot them, and get them corrected. So I'm very grateful that we're actually aware of the situation, and now we know we can correct it.
Thank you so much. Next, we'll have Emery Kelly with Florida Today.
Hey, folks. I think you actually kind of maybe just answered that a little bit, but and perhaps this is kind of a strange question, but if the rehearsal had went perfectly, that's one thing. But is it? And I don't want to use the word better, but is it almost better that something came up, from an engineer's perspective, working on this rocket all this time? Is it sort of preferable that things are coming up and you can kind of see what they are right now? Thanks.
I'll let John answer that, but in my opinion, yeah, I think that's actually a good thing. John, go ahead.
Well, certainly you don't want to have failures in flight, and that's why you test on the ground, right? And so that's true now. And in this case, we do have redundant systems, but I mean, I can't say I'm pleased that we have a broken part, but I am glad that we caught it when we did, before we got into any operations that would be compromised by having a broken part. So yes, whenever something breaks, but that's why we do these thorough tests before we get out there to the pad, and that's why we have launch commit criteria, and why we have different checks all the way through count, whether that's a wet dress or whether it's just an engineering test in the VAB, and so there are things like this that come up in a system that has a lot of components. You keep the systems as simple as you can because that promotes mission success, but yet because of the complexity of the mission, that does drive a lot of components, and sometimes they fail, and we monitor all the critical ones, and I'm glad we caught this.
Yeah, and I think, Charlie, to be a good thing. We maintain a really positive attitude about this stuff. It may seem almost a little unusual, but this is really important, that if you're going to fly these type of vehicles for the first time, you really have to have a learning attitude, let's see what we've got type of thing. And I think that's what I'm really proud of the team for, too, that this is really a mentality that you have to maintain to as you go through this, take it a step at a time, look at the data, see what it tells you, try not to prejudge it one way or the other, but really let the data kind of drive you in a good direction. And I think this team has done an outstanding job with that. The plan we have right now will help us get that much farther along. I mean, Charlie, you've been doing a lot of operations. I mean, any thoughts on this? Or?
No, Tom, I think you said it. I mean, we're at the beginning. This is the first flight of a program that, is intended to last for years, to take us back to the moon, to accomplish amazing things, and one day to go on to Mars. And so when you think about that investment, and you think about the first flight, you have to expect that you're going to learn things. You hope that you'll learn them as kind of John Blevins described in a time frame that allows you to continue on in a timely manner. But learning is part of it. You can't have a first flight and not have some learning. And so what do you do when something happens? I mean, you adapt. You look at the data, you develop a plan, you adapt, and you let the data lead you to the next step. And that's what we're going to do in preparing this amazing vehicle to go fly.
Thanks, Charlie. Next, we'll have Philip Sloss with NASA Spaceflight.
Thanks. I think this is for Dr. Blevins. I guess I just wanted to verify the location of the check valve a little bit more. Is it kind of on the mid-body structure where we see the COPVs? Is it in that area, basically? Thanks.
Yes, it is. It's in the mid-body. You would access it through the LVSA if you're familiar with the rocket. There'll be an access hole right there, and you get in. If you stand on the platforms, it's just about neck high on a typical person, and so it's pretty accessible. And you're right, it's right there in the mid-body.
Thanks so much. Next, we'll have Stephen Clark with Spaceflight Now.
A detail of the operation plan for Thursday. Will you be flowing cryogenics just solely up the transfer lines on the ML up to that interface with the ICPS during that chill down, or will any cryos actually be afloat through the plumbing in the engine or the vehicle during chill down, or is it solely on the ground side that you'll be flowing cryos leading up to the ICPS?
Hey, I'll say a few words here because we've been working this today, quite honestly, and then let Charlie kind of clean up if I mess up what I'm telling her. We're going to flow through the ML part that you just mentioned, but we are going to flow cold temps into the vehicle, monitor those temperatures. When they hit cryogenic temperatures, that's when we're going to stop. So we're going to get a lot of data about flowing that cold gas across those interfaces right up to the point where we would start what we would call fast fill. Charlie, do you care to add anything?
No, John, I think you covered it well. I would just say the only add I would have to it is I think that's a really important piece of data to get, because historically when you see leaks, especially with something small like hydrogen, it is usually when you get down to cryogenic temperatures, and so we're excited to see the data that we get from chilling down that QD to cryogenic temps.
Thank you. Next, we'll have Jim McKenna with Aerospace Tech Review.
Thank you. Going back to the last attempt regarding the manual hand valve, what have you determined about the causes of that error and steps to be taken to prevent its recurrence on that hand valve and any other hand valves in the system?
So we have, as part of our walk down, our system verifications, we have enhanced the walk downs and the verifications of each of those, not just on the LH2 side, but across our systems, and we'll be talking about that tomorrow at the pre-test briefing. We've also added some verifications in this particular case. There are some things that we can do to ensure that we are in the proper configuration, and procedurally we've added those in as well.
Thank you. Next, we'll have Christopher Kokinos with Astronomy Magazine.
Yeah, thank you. Appreciate the updates and good luck this week. I have actually a logistical question. I think it's Tiffany, the PAO here on the call. But once the wet dress rehearsal is over, will you have a summary, like a bullet point summary of the key nominal findings and some of these off nominal events? I'm just wondering if that might be possible. But For Charlie, I want to make sure I understood your earlier response. The two main things that we're not going to be seeing are, if I'm following this correctly, are the loading operation, right? Complete loading of the upper stage. And then I think you said there were 3 commands for the upper stage that won't be tested. So I just wanted to check to see if I had that correct. Thank you.
Yes, you have it correct. So the things that we would be unable to achieve in total is the loading of the cryogenic propellants in the upper stage, and then there are some functions that we verify as part of our critical events in terminal count that we will not be able to do, and there's a couple of commands that go from our ground launch sequencer to the ICPS upper stage that we will not be able to complete as planned.
Yeah, and let me just add, this is one of the things I probably should have brought up. You know, upper stage is a lot different than main stage. When we get down the terminal count sequence, we're getting ready to fire up the engines, and therefore we do a lot of conditioning and preparations to allow that to occur. Upper stage is just basically fill the tanks, make sure all the hardware is talking, and make sure you're seeing systems status the way you'd like to, but you're really not going to fire up those engines until you get up into orbit. And so there's a big difference between, you know, the main stage portion of this and the upper stage portion. We'll see a lot of the important commands through the terminal countdown sequence, but it's really about getting ready to do T0 ignition and making sure you've got a full upper stage that's looking nominal like any other upper stage normally would look nominal. If you build it up and it's got nominal parameters, that's what you're looking for. This is not, it's slightly different in terms of the time sequence criticality, particularly when you're checking out the ground side of the events. And so it's just kind of an important distinction. It's really a lot of, and Charlie's right, you know, the tanks are much bigger in the core stage. There's a lot of stuff going on. We're really getting ready to get things ready to get into the start box. The upper stage, we just need to make sure we got an up stage that's talking to us, it's healthy, and it's full of gas. That's what you're looking for.
Thanks, Tom. And Christopher, you can feel free to reach out to me directly with any additional questions that you may need answered. Next up, we'll have Chris Gabehart with NASA Spaceflight.
Yes, thank you. I think it's a clarification question for Charlie. You mentioned that you'd let the data from the modified wet dress on Thursday sort of drive the forward decisions for what you will do next once the helium check valve is replaced on the ICPS once you're back in the VAB. But I admit I'm a little confused on this. How are you going to get that data if you don't actually fuel it? What is the data you're looking for from the ICPS on this modified wet dress without fueling it that would give you the confidence to be able to make those determinations of what the next step would be? Thank you.
Yeah, so let's see. I'm going to take this in a couple of pieces. So when I talk about letting the data lead us, remember that we're getting data on the loading of the core stage. The liquid hydrogen we have not loaded, so that will be an important gate for us. The terminal count will be an important gate for us. There's a number of, as I said, there's about 75 to 80 functions commanded from the ground that are all very dynamic in the terminal portion of count. That will be data that we get that will inform our path forward. So it's not just about the data that you don't get relative to ICPS. It's really about the data that you get on the boosters. It's the data that you get on the core stage. Again, there's a lot of dynamic test and activity that happens in terminal count. And so we want to, so it's about that piece of data. And we'll take all of that. We'll take the data for the systems that work exactly as we expect them to. We'll look at where we get in terminal count. We'll look at the data that we didn't get, that we plan to get as part of this. And we'll take all of that that data, and we will go through and, like we do any other kind of issue, right? We'll sit down, we'll look at, you know, what is the information that we have, what is the information that we're missing, is there an opportunity to get it in some other way? If the answer is no, then we'll look at the risk associated with that, and we'll put a plan together to address that.
Thanks, Charlie. Next, we'll have Ken Kramer with Space Up Close.
Hi, thank you. Yeah, I want to follow up on this upper stage. I'm curious, it sounds very much to me like you may very well have to do another wet dress rehearsal after you replace this valve. So related to that, I'm curious to know can you do just a loading of the upper stage, or do you have to first load the core stage before you could do the upper stage? And if you could do just the upper stage, would there be any value to that, maybe not rolling back to the VAB again? Thanks.
Yeah, hey, I'm going to echo something Charlie just said before we get started, and I know engineers come across negative, so I want to say this vehicle's doing great. It's doing what we asked it to do once again. But first of all, you know, we're calling it wet dress, and so we're focusing a lot on propellants and liquids here. There are so many things we're checking, and most of those answers that we're looking to get aren't yes or no. They are, what is the temperature at this interface in these conditions, and how does that validate our model to expand that to the full flight envelope that we might launch? And many of those questions will be answered for ICPS when we flow these cold propellants across the QD to the point just getting to fast fill. Now, to answer your other specific question, so I guess one, I don't think I can answer, and Charlie's not answered, and I don't think any of us should answer what the data is going to look like to tell us whether we should do another wet dress. And we're ignoring a preponderance of the systems here when we focus on ICPS that may tell us whether we need to do another wet dress or not. It's really not that if that missing data, I'll just say if that missing data were the only missing data and every model acted perfectly, I think we would look long and hard at whether we needed to or not. But there's a lot of information we're going to be gathering on Thursday. So, but to answer your specific question, we would need to do operations on the core stage tanking in order to tank the upper stage, your second question.
Thanks, John. And we've got time for one final question, a follow-up from Irene Klotz with Aviation Week.
Thanks, Tiffany. If everything goes as planned on Thursday, what's the nominal timeline to roll back to the VAB? And can you just refresh our memories of the windows for Artemis 1 launch in June, if that's still an option, in July and August? Thanks.
Well, let's see, Mike, did you want to talk about the windows, and then I'll talk about the timeline for rollback?
Yeah, I can do that, Charlie. So for the June windows, we've got, I'm looking at my data table here, Irene. We've got June the 6th through the 16th. That's the June or the early June window. We've got June 29 through July 17. That's kind of the late June, early July window. And then if you want to look out even beyond that, we've got a window starting in late July, July 26th through August the 9th. Those are the next launch periods where the Earth-Moon alignment supports our the physics and the vehicle's ability to get there and get home safely.
And then with respect to post-wet dress, we do have all of our post-stops to go do. That does run us about a day or two. We also have deservicing of the boosters planned, and then we'll do preps for roll. And that does put us about, from wet dress to roll, somewhere around about 10 days.
Thank you all for joining us today. You can listen to a replay of this teleconference online by visiting the Media Resources tab at www.nasa.gov/Artemis-1 later this afternoon. To follow along with updates for the wet dress rehearsal test, please go to the Artemis blog at blogs.nasa.gov/Artemis and join us on the NASA Exploration Ground Systems Twitter account. You can also watch a live stream of the rocket on the pad at the KSC Newsroom YouTube channel. Thanks again, and that will conclude our call.